Welcome to another edition of Final Countdown. Now today we'll be discussing week 13 day 2. Week 13 day 2. Right. Let's dive in. Right. Read the question. A monochromatic ray of light passes through flow layers of transparent plastic with refractive index N1, N2, N3, N4. If the emergent ray is parallel to AB, so nothing much to think. Emergent ray is parallel to the incident ray. The angle made with the normal will be the same. They are parallel. Parallel means refractive indexes are same. Guaranteed you can say N1 equals N4. N1 equals N4. Yeah. So if the refractive indexes are same, incident and emergent will be parallel to each other. Here, incident and emergent will be parallel to each other. Okay. Moving on. If the length and arrowhead represent the magnitudes and directions of air molecules, which of the following correctly shows the displacement of air molecules when it resonates at the first overtone? Now first overtone, all of you all know, will be something like this. Node, antinode, node, antinode. Node, antinode, again node, antinode. Correct answer is answer number 3. Correct answer is answer number 3. So here it's sensitive for pressure variations. Figure shows a speaker mounted at B at a certain distance from a smooth wall A, emitting a sound of single frequency. When a sound detector which is sensitive to pressure variations is taken from A to B, minimum sound level is detected at 2 meters from the wall. There. So when I move from A to B, minimum sound is detected 2 meters from the wall. Right. Speed in air is 320. So what we can say here is very simple. This is like your eardrum. Pressure antinode. Here pressure node. 2 meters. Pressure antinode, pressure node. So here we can say lambda divided by 4 is equal to 2 meters. Lambda is equal to 8 meters. V is equal to F lambda. V is equal to 320. F lambda is 8. F is equal to 40 Hertz. Frequency 40 Hertz, answer number 1. Moving on. A mercury glass thermometer made of a glass capillary of uneven bore radius when calibrated against a correct thermometer produces the curve shown in the figure. The correct thermometer is here. False thermometer is here. Okay. Correct thermometer, false thermometer. Here theta P is the reading of the correct thermometer and theta F is the corresponding reading of the uneven thermometer. Several students have deduced that the shape of the bore of the capillary tube by considering the above curve as follows. Which of the following figures represents the best model for the shape? Look at this carefully. Now a correct thermometer increases there. False thermometer, the increase is even larger. There. Different cross-sectional areas. So temperature increase here is represented by a larger temperature increase there. What can you say? Larger temperature increase means larger expansion taking place. Larger temperature increase means larger expansion taking place. This means the bow area is small. Right. Then look at the next one. Increase from here to here. Here the increase is small. Smaller increase means larger area. So larger area means this is also second part should be larger. So 2 and 5 both are wrong. 2 and 5 both are wrong. What can you say here? Small increase here becomes a large increase. That's because the cross-sectional area is what? Smaller or larger? Larger increase will always give smaller cross-sectional area. Smaller cross-sectional area. So if you look at this, small area, small area, small area. Right. Next one, correct reading here. Smaller ice. Smaller ice means larger cross-sectional area. Larger cross-sectional area. So compared to these three, larger cross-sectional area is here. Final part. Small temperature increase, larger means bow area is small. Bow area is small. So here bow area is large. Bow area should be smaller. The smallest bow area. So these are also wrong. Only correct answer is answer number 3. Only correct answer is answer number 3. Clear? Because check and see. For the same increase here small increase. That means area is large. Same increase here, large increase. That means cross-sectional area is small. Small increase here, actually large increase here. That means cross-sectional area is small. Correct answer is answer number 3. Right, moving on. Heat is supplied at a steady rate to a block of ice in a container at 0 degrees Celsius. After a time t, the block of ice has converted completely into steam at 100 degrees Celsius. Specific latent heat of fusion of ice is given. Specific heat capacity of water is given. Specific latent heat of vaporization is also given. Here, all these are given. Heat is supplied at a steady rate to a block of ice. After time t, the block of ice has converted completely to steam at 100. Neglect the heat capacity of the container, the heat loss surroundings. After time t over 2. Now interesting, huh? Ice at 0 converts to water at 0. Water at 0 converts to water at 100. Water at 100 converts to steam at 100. Now latent heat here is M3 10 to the power 5. M 4000 change in temperature is 100. Here M 2 10 to the power 6 latent heat of vaporization. Total time taken is given as T. Right. What do you think? Where do you think it will take a longer time to heat? Longer time to heat because here it will take a larger energy. Even if you solve this, 0.4 M 10 to the power 6. This is 0.3 M 10 to the power 6. So the longest time taken here, this put together, both of them put together, the amount of heat is 0.7 M 10 to the power 6. Here 2 M 10 to the power 6. Just think like that. Total time is T. So half a time means Half a time means if I take the total energy 2m, 0.7m, 2.7m. 2.7m divided by 2 is 1.3m. Where is 1.3m? Here. There is a mixture of water and steam. Correct answer is answer number 5. Understood, no? Here 0.3m, 10 to the power 6. 0.4m, 10 to the power 6. Altogether 0.7m, 10 to the power 6. Here 2m, 10 to the power 6. So total amount of energy absorbed is going to be 2.7 10 to the power 6 in time t. Half a time means, let's say, half the energy, steady rate. No? Steady rate means then 2.7 divided by 2, 1.3. Where is 1.3? Up to here 0.7, 1.3 will be somewhere here. Mixture of water and steam. Here, mixture of water and steam. Question number 6. Question number 6. Okay. Figure shows an iron wire fastened to a brass frame. At room temperature, the wire is neither slack nor under stress. The linear expansivities of brass and iron are 18 10 to the power minus 6 and 10 10 to the power minus 6 respectively. So brass and iron, who has the bigger expansivity? Brass. Young's modulus of iron is given. When the temperature of the whole system is increased by 1 degree, stress on the wire will become. What will happen? Brass has more expanse, it will start bending in. So here he is also expanding. Y alpha area delta theta. We are talking about the stress, force over area, Young's modulus alpha delta theta. Think carefully now. Brass is also expanding, iron is also expanding. If brass is also expanding, iron is also expanding, what can you say? You can say there is an effective alpha. Effective alpha you can represent here easily. Effective alpha you can represent here. Young's modulus 3 10 to the power 9. Who is expanding more? Brass is expanding more. 18 minus 10 10 to the power minus 6. Change in temperature is 1 degree. 30 multiplied by 8 10 to the power 3. 240 10 to the power 3. Simplify this. 2.4 10 to the power 5 Newton per meter square. 2.4 10 to the power 5 Newton per meter square. There you go. Right. So, 6th one, correct answer 1. Correct answer 1. MCQ 7. 3 arrangements A, B, C made up of identical capacitors of capacitance C are shown in the figure. Equivalent capacitance of the arrangement in ascending order will be ascending. Equivalent capacitance. What do you all know? Capacitors in parallel are like resistors in series. Parallel means 3C. Parallel means 2CC. That means 2C multiplied by C divided by the addition, which is going to be 2C divided by 3. Here capacitors in series are like resistors in parallel. C times C divided by 2C, that's going to be C over 2. C over 2C, 3C over 2. Ascending order means increasing order. Smaller one, slightly bigger, larger. BCA. BCA means correct answer is going to be answer number 2. Correct answer is going to be answer number 2. Right. Moving on. Equal currents I flow through 3 isolated wires ABC. Where A is a circular loop of radius R. B and C are infinitely long wires. If BA, BB, BC represent magnitudes of the magnetic flux density at the center respectively. So here current is going in that direction. Current is going in that direction. Field at the center is outwards. Mu naught I divided by 2R. Field coming outwards. BA. Infinite long wire. infinite long wire. Next is infinite long wire. Current is also coming downwards. Here you go, mag field in that direction. Current is coming downwards. Current downwards, field outwards. Here also field outwards. Current magnetic field is mu naught I divided by 2 pi r plus mu naught I over 2r. 2r. There you go. Both are acting outwards. This is BB. Next one. Current is going downwards. He is also acting in the opposite direction. Current down, field outwards. Current down, field outwards. Clockwise means inwards. So who is bigger? This is going to be bigger, inwards. Mu naught I over 2r minus mu naught I over 2 pi r. He is acting inwards, BC. They are asking which one is bigger. Obviously this is going to be bigger, no? This is going to be bigger. So BB is bigger. He is going to be smaller. BA, BC. BB, BA, BC. BB is larger than BA, larger than BC. Correct answer is answer number 2. Correct answer is answer number 2. Right. Moving on. In the circuit shown, V0 represents the voltage of a battery with negligible internal resistance. No internal resistance here. Remember, whenever you get a problem like this, very simple. Variable resistor, either it's going to be 0 or infinity. That's all you have to vary. Variation of voltage V. What's the voltage V? With R2. So R2 can vary from 0 to infinity. Don't forget. Right. So we start from basics. What if this resistance is 0? Short circuit. Short circuit means current will divide. Current will divide. Current will divide means these two will be parallel to each other. So when R2 is equal to 0, these two are parallel to each other. Voltage here and voltage here both are same. P is equal to V0. Yeah? V is equal to V0. So very basic representation. Huh? V equal V0 is there when R2 0. D wrong, D wrong, D wrong. Even I think D is wrong. Starting from low value, D is wrong. Only that is there. Let's check. Next, R2 is infinity. R2 is infinity means open terminal. Open terminal means current is not passing through. Open terminal. Current is not passing through means no current here means no potential difference here. So R infinity means V is tending to 0. Only correct answer is answer number 5. Only correct answer is answer number 5. Okay, right. Moving on. MCQ 10. In the circuit shown, batteries have negligible internal resistance. Which of the following is not true with regard to the magnitudes of the currents in the circuit? What is not true? So let's try to apply Kirchhoff law. So I4 is equal, I3 plus I4 equals I5. Yeah. Here I1 equals I6 plus I4. Right. Let's apply Kirchhoff here. Let's apply Kirchhoff here. Let's apply Kirchhoff here. Loop 1, loop 2, loop 3. Just correct. Loop number 1. Sum of EMF equals sum of potential differences. Minus plus, plus minus. 0. I 4 times 2R guaranteed I4 is going to be 0. I4 0 for sure. I4 0 for sure. Right now, if you apply basic Kirchhoff, right, no, they are asking not true, so this is true. You'll find the true statements very easy, right? When you apply Kirchhoff loop number 2, sum of EMF, sum of potential differences. Positive V, what can you say? 2R I1, here no resistance, right? Loop 2, loop 3, V is equal to 2R I3. Think carefully with you. So I1 is also existing, I3 is also existing. I1 is V over 2R. I1 equals I3. V over 2R, V over 2R. These is also correct. These also correct. Right. Next, I1 equals I6. I1 equals I6. Correct, no? Here current is 0 means I1 is the same current I6. Correct. Here current is 0 means I3 equals I5. That's also correct. So wrong statement will be answer number 3. Answer number 3. Okay, no? Wrong statement will be answer number 3. Okay. Moving on. 2 identical batteries. 2 identical batteries having negligible internal resistance is connected in series as shown in the figure, are capable of delivering power to a load resistor of resistance R at a constant rate P for a time t0. If only one of the 2 batteries is connected across R, it will deliver power at a constant rate. 2 identical batteries have negligible internal resistance connected in series, deliver power to a load resistor R. Okay. Right. So here supply voltage is 2V. So power given by the battery is 2VI. Current is going to be I. Okay. Now, if only one battery is working, the current will be exactly half, I over 2. Current will be exactly half. Here current is I, one battery means I over 2. Right, I over 2. It will deliver power at a constant rate of, right, what will happen? Power P dash, voltage V, current is I over 2. Current is I over 2. So VI divided by 2. VI divided by 2. What is VI? P over 2 times 2. P over 4. So power delivered here is P over 4. Power delivered is P over 4. Right? Now the next one is how long will it deliver? Power P over 4. So that won't be much of a problem. Okay? Now if you look at this, power delivered by these 2 batteries, let's say here T0, for a time T0. How long will it be here? How long will it be here? So you look at the time there. So these wrong, these wrong, these wrong. One of the 2 answers. One of the 2 answers. So now how will you find the time taken? Power supply I squared into resistance. I squared into resistance. Power absorbed by the resistor. Here you go. I squared. Here I squared into R. I squared into R times T naught is the energy. Energy absorbed or power dissipated, I squared R over T naught. So we will take this I squared R power over time T naught, that is the power given P. Now the current is I divided by 2. I divided by 2 squared RT, power is going to be P divided by 4. Look at the board carefully. P divided by 4. So here the power transferred for a time T naught. What can you say here? Now when the current reduces, power can be transferred for a longer time. Obvious, no? Bigger current, quickly it will discharge. Smaller current, it will travel for a longer time. Here, smaller current. So looking at these two, smaller current will discharge for a longer time. Correct answer is answer number 5. Correct answer is answer number 5. Okay. So here you can directly come into that basic conclusion. So here, supply delivered, different story. Smaller current means it will deliver power for a longer time. Okay. Discharge is small. Here discharge is large. Larger current. So there you go. Answer is answer number 5. Question number 12. Question number 12. Have a look. In a potentiometer circuit shown, V0 represents the voltage of a battery with negligible internal resistance, and E represents a cell with finite internal resistance. Variation of the balance length is best represented by, so I'm going to change R. So R can vary from 0 to infinity, no? If the resistance here, negligible internal resistance, finite internal resistance, there is an internal resistance, right? So when R is equal to naught, if I apply Kirchhoff, current is going to be I1, E is going to be E divided by simple R plus R0 is going to be I1. Okay. So terminal potential difference here. There is a terminal potential difference. E minus I1 R. That is same as I1 R0. Terminal potential difference. E minus I1 R is same as I1 R0. There is a balance length here. Okay, right. Now when R goes to infinity, current will not flow. No current is flowing means now your terminal potential difference is going to be E. Here lesser voltage, lesser balance length. Higher voltage, higher balance length. If you write the general equation here for the current, E divided by simple R plus R0 plus R. So when R is increasing, current will reduce. Current will reduce means terminal potential difference will increase. Right. So So already when R equals 0, there is a terminal potential difference. Third one is wrong. Third one is wrong. Fourth one is wrong. Fifth one is wrong, no linear drop. So resistance increases, current reduces, terminal potential difference will increase. It's not a reducing curve, increasing curve. So only correct answer is, for the 12th one, answer number 1. Answer number 1. Okay, right. Moving on. In the circuit shown is made up of ideal elements. When a sinusoidal voltage of peak amplitude 5V is applied to the input, a waveform of the output voltage will be V0. Right. So you can see a diode connected here. Input voltage here positive. High potential, low potential. So positive half comes in. Potential at A is greater than potential at B. That means forward bias. Here, forward bias. High potential, low potential. Imagine like that. Right. So what will happen if you apply here? They are asking the voltage V0 here. Voltage V0 here. So 5 volts applied there. Across the silicon diode 0.7. Up to 0.7 current is not allowed. After 0.7 current is allowed. So up to 0.7 there is no current allowed. After that current is allowed. Here. After that current is allowed to pass through. So here charging will take place. Charging will take place. Think of it very carefully. Okay. Now when the negative half comes in, potential at B is larger than the potential at A. There is no current passing that way. No current passing that way. They are asking you, no current passing that way means here if there is a load there will be a discharge. No current passing that way. Reverse bias. So they are asking the voltage here. Think carefully and answer. Now look at this carefully. If I apply Kirchhoff law here, minus to plus, battery here, minus to plus, plus to minus, effective EMF is going to be 5 minus 2, 3 volts. 5 minus 2, 3 volts. Here. So until 0.7 volt is reached, no current is passing through. So until 0.7 there is no voltage represented. Effective voltage is represented here. Right. Okay. What can you say about the negative half? Negative half means terminals are in the opposite direction. Terminals are in the opposite direction. No current will pass through. This is going to be reverse bias. That's going to be reverse bias. Okay. That's going to be reverse bias. What can you say about the voltage drop? No current. But what can you say about the voltage? Here. What can you say about the voltage? Reverse bias voltage will act across this. So here 3 volt is acting. 3 volt is acting. Capacitor is there. Capacitor will do the smoothing job. This is the smoothing curve. So here if I just purely mark it, diode, battery, output. Let's say there is a load resistor here. Let's say there is a load resistor here. Positive half, it will increase up to 3 volts. Increase up to 3 volts. Negative half, no current is passing through. No current is passing through means it will drop to 0. Again positive half, it will increase. Here, like that it will go. But since there is a capacitor, capacitor will charge, discharge. Charge, discharge. So smoothing curve will take place. Smoothing curve will take place means only correct answer is answer number 3. Only correct answer is answer number 3. Okay. Right, moving on. MCQ 14. Which of the silicon diodes transistors shown operates in active mode? Now what's the condition for active mode? Active mode is VC is greater than 0, less than VCC. Generally, if you can operate VCE at VCC divided by 2, it's ideal. Yeah. VCC divided by 2 is ideal. Right. So here, this is wrong. Base emitter forward bias. Here reverse bias. Base emitter forward bias. Here 0.3, that also won't work. Silicon, it won't work. So here this also won't work. Here 0.7, forward bias correct. Here potential drop is there. Here 1.2, this also won't work. Forward bias and VCC at a high potential is given only in answer number 4. Only in answer number 4. Question number 15. A plate of copper 2 10 to the power minus 3 millimeters thick and 4 10 to the power minus 2 wide. Current 80 ampere is passed through. 80 ampere is passed through. Right. What is the number of free electrons per unit volume? All voltage is by net. All voltage generated 0.8 10 to the power minus 6. Magnetic field strength 0.4. Current is 80. N. Charge of electron 1.6 10 to the power minus 90. Thickness is parallel to the magnetic field 2 10 to the power minus 3. Simplify this. 32 3.2 10 to the power minus 21 0.8 10 to the power minus 6. Jump a decimal 10 to the power minus 27.8. 100 divided by 8 10 to the power 27. 1.25 10 to the power 28. 1.25 10 to the power 28. Correct answer calculate carefully. Minus 27 10 sorry 10 on top 100 12.5 right 0.8 10 to the power minus 6 0.4 into 80 n 1.6 10 to the power minus 19 2 10 to the power minus 3. Simplify it. Simple n, that's going to be 32 3.2 10 to the power minus 21 0.8 10 to the power minus 6 0.8 10 to the power minus 6. So check this calculation carefully again. Right. So here if you calculate it, n is 32, jump a decimal 2 there, 32 times 8 10 to the power minus 27, 32 1 32 100, 8 times 1 12.5. So 0.4 into 80 divided by n, 1.6 10 to the power minus 19, thickness 2 10 to the power minus 3. These are the mistakes. Should be 22. 22 means here 28. That means n is 1.25 10 to the power 29. Correct answer is answer number 1. Correct answer is answer number 1. Okay. Right. Moving on. A thin disc has freedom to rotate about the axis passing through as shown in the figure. All the forces are equal in magnitude. Consider the following statements made regarding this. Maximum torque is produced by force F2. Actually F2 is smaller distance. It can't be the same. A wrong. Whatever A wrong. Rotation of the disc due to the resultant torque will be clockwise. Clockwise. Distance. The majority clockwise. Correct. When the magnitude of the forces are double, the magnitude of the torque will also double. So all the forces double means torque also will double. B and C correct. Answer is answer number 4. Question 17. Figure shows Hay's apparatus used to compare the density of two liquids A and B. If the same experiment is done by changing the position of the limbs. So actually, does hair depend on the location of the beakers? No. Independent. So the height here and the height there should be the same. It can't differ. It can't change. So the height measured from this surface there and the height measured from here there should be the same. Because it is independent of the location of the beaker. Independent of the location of the beaker. So this is wrong. Heights have changed. These become small. That is also wrong. This has become longer. That's also wrong. This has become smaller. That's also wrong. So only correct answer is answer number 2. Answer number 2. Because the height should not change. Same height. They can't change. If this is H1, this should be H1. If this is H2, this should be H2. No change. Question number 18. 3 uniform objects shown in the figure have equal masses. Object A is a solid cylinder of radius r. Object B is a hollow thin cylinder of radius r. Object C is solid cube whose sides of length 2r. If moments of inertia are shown, which is the largest? Right. The solid cylinder will have the smallest moment of inertia. Hollow one is large. That is true. No? IB is large. Now out of these two, who is larger? That's the only objective. Here. Now if you take from the axis to this corner, distance r. So here if I take it 2r, Pythagoras theorem, 2r squared times 2 whole thing square root 2 times 2r, that you divide by 2 root 2r. So comparatively this distance to the corner is larger. IB is larger than IC, larger than IA. This will be your relationship. IB larger than IC, larger than IA. Correct answer is answer number 2. Answer number 2. Moving on. Particle of mass m1 moving with a speed v along the positive x direction collides elastically with another particle of mass m2 at rest. m1 is traveling with a velocity v1, collides with m2 at rest. Which of the following statement is incorrect? If m2 is larger than m1, elastically, m2 larger than m1, after collision, both of them will travel in opposite directions. m1, m2 will move in minus and plus direction. Statement 1 is correct. If m1 is larger than m2, both m1 and m2 will move in the positive direction. That's also correct. m1, m2 would move together as a single object with a lower speed than v in the positive x direction. This statement is wrong. Why? Moving together means inelastic collision. Here, moving together means inelastic collision. So they are asking the incorrect statement, guaranteed this is the incorrect statement. So moving together means, don't forget, inelastic. Right. MCQ 20. As shown in the figure, spaces between the nylon fibers of an umbrella made by nylon cloth will be considered approximately circular if the diameter of these spaces L and density D, the minimum surface tension of water should to prevent water from seeping out. So look at this carefully. Like this the water droplet will be there. Okay. Like that the water droplet will be there around the circumference. Okay. Around the circumference. So diameter is L. Diameter divided by 2 is going to be L divided by 2. Diameter divided by 2 is going to be L divided by 2. So surface tension forces acting upwards balances the weight. Surface tension multiplied by circumference, 2 pi L divided by 2. Balances weight, hemisphere, 4 over 3 pi r cube into half rho g. Simplify it carefully. T times 2 pi L over 2, 2 over 3 pi, radius is L over 2 cube, dg, density dg. L over 2, 1 L over 2 cancel off. Pi, 2, 2. T equals L squared, 4 times 3, 12, dg. What are they asking? Surface tension. L squared over 12. L squared over 12, dg. Correct answer is answer 4. So these like a hemisphere. Hemisphere weight balanced by the surface tension force. 2 pi radius is L over 2. So sum of forces in the upward direction balances sum of forces in the downward direction. Okay, right. So this concludes week 13 day 2 part 1. We have completely discussed the MCQ because from 2011 there have only 50 MCQs given. And the middle part of the MCQs are actually difficult. So it takes time to discuss. So therefore I have broken this into 2 parts. So week 13 day 2 part 1. And the part 2 will be discussed in the structured essay and the essay. So see you all soon.